Hello. In this session, we'll discuss about hydrogen spectrum. Hydrogen spectrum is emission spectrum. By applying high potential difference in a discharge tube containing hydrogen gas, a bright light is obtained. A bright light. This light, when passed through prism, an emerged beam of light is collected over photographic film. The beam of light which is collected over the photographic film is called hydrogen atomic spectrum. Hydrogen atomic spectrum is line spectrum. I will explain you in this session only what is the differences between line spectrum and band spectrum. So hydrogen spectrum is atomic spectrum and it is line spectrum. What is atomic spectrum and what is line spectrum? Differences between line and band, absorption, emission spectrum, all will discuss in this session only. Before that, we'll complete first hydrogen spectrum because the differences you should know, that's all. They won't ask you much. Absorption, emission spectrum, atomic and molecular spectrum, line spectrum, band spectrum, these differences we'll discuss definitely. So hydrogen emission spectrum is a line spectrum. So spectrum means, in simple word you can say it's a color photograph type beta. Okay, now whatever the photographs you are saying, this is like a, you can consider this as a spectra. Okay, the rainbow you can consider like a spectra. And hydrogen atomic spectrum contains series of lines beta. Actually what happens here is, for example, let us say these are different energy levels. I'm just giving the numbers to them. First level, second level, third, fourth, fifth, sixth. If you want, you can take one more, that is seventh level. When you are giving energy, the electron is jumping from first level to, it may enter into second level or third level or fourth level. Any one level it is jumped better. Okay, so what is hydrogen's ionization potential? That is 13.6 electron volt per atom. 13.6 electron volts of energy if you are giving to an atom, the electron simply escape from the atom bit. Escape from the atom. So what you have to do is, you need to give less than 13.6. Okay, for example 13 electron volts of energy if you are supplying bit. So the electron which is present in the ground state beta, this is we are calling as ground state. From here, by absorbing that energy, whatever the energy you are giving, it will try to jump into higher levels. Any one of the higher levels it will be trying to jump depending on the energy you are giving. If you are giving more than 13.6, it will simply escape from the atom. Okay, it will be completely out of the control of the atom, out of the attraction of the atom. We are calling that is ionization. So give less than 13.6, less than 13.6, 13, 13.1, 13.2. So minimum energies are also required, that also we'll discuss now. So when the energy is given, so electron will be exciting. We were discussing the same lines in Bohr's model. This kind of process is called excitation. Jumping of the electron from the lower orbit to higher orbit is called excitation. After reaching this excitation, it can't be staying here forever. Okay, now it will be coming back. It has to come back. For example, a normal simple example will take, life example will take. For example, India versus Australia match is going on. For example, I am saying, but I am a very big fan of India. For example, India versus Australia match is going on, and last over, India needs to make 6 runs only. Last over, the batsman is in strike. First ball defense, second ball defense. When you are seeing the live match, you will be getting angry. You will be saying that, अरे ऐसा कैसे हो रहा है? अगर मैं हूँ तो वहाँ पे third ball defense, fourth ball defense, your angry is getting into peaks better. Fifth ball still defense, otherwise single run. You lost your all your hopes and you got complete frustration. You almost all types of scoldings are coming from your mouth. That अगर मैं वहाँ पे होता तो 6 रन बनाने के भी ये बना, all this will come better. Let's take it as an example. After the last ball, India didn't make 6 runs and it has lost the match. Then you will be in a particular disappointed mood for some time. If any of your cousin is sitting by the side of you, you'll be shouting, this fellow always makes like that only, he never plays like this. All nonsense things, all nonsense stupid words will come from your side. If your friend or cousin is also like that, then he will also add some masala to that one. So all this will go on till what time? Till what time? 10 minutes, 15 minutes, half an hour. Then mom comes, बेटा आ जाओ, आपके लिए पालक पनीर रेडी है. Then everything will be normal. Ah, mama coming, you'll be going, and everything is normal. Then you'll be reading your books, you'll be reading some story books, you'll be watching your favorite movie. That's it. Next day routine life better. So from that excited mood you are coming back to the original state better. For example, आफ्टर 1 hour also you are behaving the same thing. साला इससे कैसे हो गया, 6 बाल भी नहीं बना सकते, रात में सोते वक्त भी ऐसे ही बोल दिए, फिर सुबह सुबह उठते भी ऐसे ही बोल दिए. Then your mom will take you definitely to a psychiatrist. You are absolutely abnormal. Okay, that is not happening with all of us. We are coming to the original state easily, normally. So here also electron must come back to the original state beta. So going into the higher levels is called excited as you are getting frustration, and coming back to the normal state is called de-excitation. Whenever we watch movies and all, we feel like ourselves as heroes. That's why movies are so pretty in India. Okay, we admire the heroes because we imagine ourselves in that role better. But when you come out of the theater, you will be normal. If you are abnormal, you will be in mental hospital. Okay, so here also electron when it is jumping into the higher levels, there it won't stay for a long time. It will come back. It will be coming back to the original level, which we call ground state. Okay, now when it is coming back, that is de-excitation, and it is going to form so many lines here. Now you see, you can ask me, sir, if it is first level, it is second level, it is third level. If electron is there, electron can go to any one level because hydrogen is having only one electron, so it can go to only one level. Not like that, but hydrogen, you are not taking only one atom. You are taking some amount of hydrogen which contains huge number of atoms. For example, 2 grams of hydrogen molecule contains Avogadro number of molecules. So 1 gram of hydrogen atom contains 6.023 into 10 to the power of 23 atoms. Okay, so all the atoms won't accept the energy in the same way. Same amount of energy they are not going to accept each atom. At the same time, all atoms are not going to release the energy in the same way. It's all like your classroom. When the teacher explains, immediately 2 3 students understand. Some students understand when the teacher repeats, and some will be there they won't understand because their concentration is not in the class. So it is, but the teacher is saying the same thing. That is depending on the way how you are accepting that one. So here also same thing. Some the electrons, if they are getting more energy, they will be excited more. If they are not getting the more energy, they are not excited more. Okay, very simple logic. Here, after reaching into the different levels better, after reaching into the different levels, you see, actually as we are moving up, the difference must be decreasing better. 1 2 3 4 5 6 7. The place may not be sufficient, that's why I didn't make that much. From any energy level, if the electron is falling to the first energy level better, any to first, you see, 7 6 5 4 3 2 1. Okay, from any to first level, that is one type of series. Any to second level, any to third level, any to fourth level, any to fifth level, any to sixth level. This will give again. Now you see, from any energy level, if the electrons are coming to the first level, then the series of lines are called the Lyman series. Lyman series. This happens in UV region. All these lines are collectively called Lyman series. But all these lines are collectively called Balmer series. This happens in visible region. This is in passion series. This is in bracket series. This is in fund series. and the last one is called Humphrey series. Humphrey, generally not mentioned much in books better, and all these are in IR region. Near IR, IR, far IR. Okay, now passion near IR, bracket IR, fund is far IR. So when the electron is falling from any energy level to the first energy level, all the lines are collectively called as Lyman series. Any to second, Balmer, any to third, passion, any to fourth, bracket, any to fifth, fund. Spelling is PFUND. Pronunciation must be only fund, don't say P fund. And the last one is Humphrey series. And the interesting points are, you see here, this line is called alpha line. This is beta line. This is gamma line. In any series, the first line is called alpha, second line is beta, third line is gamma, alpha, beta, gamma. Any series, but first line means the difference is 1. Second line means the difference is 2. 2 to 1, difference is 1. So these lines are called, particularly these lines are called alpha, beta, gamma, or first, second, third lines like that. So Lyman series, Balmer series, passion, bracket, fund. I'll give you in a table type. Lyman series, Balmer, passion, bracket, fund. If you want, you can add Humphrey also. N1 value from where to where it is coming, to which level it is coming, beta 1 2 3 4 5. From where it is coming, it can come from 2 3 4 so on, 3 4 5 so on, 4 5 6 so on, 5 6 7 so on, 6 7 so on. Where it happens, UV region, visible region, all the rest are in the IR region. Lyman series, Balmer series, passion series, bracket series, fund series, if you want to add Humphrey series. N1 values, N2 values, where the region. One extra line you can add here is, this is alpha line, this is beta line, this is gamma line. 2 to 1, Lyman series alpha. 3 to 2, Balmer series alpha. 4 to 3, passion series alpha. First line is called alpha line. Then for each line, they can ask you the energy or wave number or frequency, anything better. For that purpose, one expression we say, that is we were discussing in previous class also in the different formulas. Rydberg equation it is called. And the Rydberg equation is nu bar is equal to 1 by lambda is equal to z square r into 1 by n1 square minus 1 by n2 square. Z is atomic number, R is Rydberg constant whose value is 1,09,677 per centimeter, or simply you can say 1 lakh, okay, 10 power 5 beta per centimeter. In meters 10 power 7 you take, not an issue, don't worry about the 9,600 value. Okay, if they are asking you exact value, that's okay, but for calculation purpose you can take 10 power 5. You will be getting almost correct answer, no problem. Not almost, you will get the answer, don't worry. And here N1 is the lower energy level, N2 is the higher energy level. This is lower and this is higher. Okay, N1 is lower energy level, N2 is higher energy level. R is Rydberg constant, Z is the atomic number, lambda and nu bar, all these are known to you. Wave number is nu bar, lambda is wavelength. Rydberg equation you can calculate for any line, any series, any line. You can find out nu bar, wave number, wavelength lambda, frequency nu, energy E, anything you can calculate, okay, by using this expression. But R is Rydberg constant whose value is 109,677 per centimeter. Otherwise you can say 110 to the power of 7 per meters. Done. Now they will ask you a few more questions related to this. How many lines are possible? For example, if the electron is falling from 4 to 1, if the electron is coming from 4 to 1, number of lines, how many lines are there? Simple, you see, 4 to directly it can come to 1 better. Otherwise 4 to 3, 3 to 1 it can come. Otherwise 4 to 3, 3 to 2, 2 to 1 it can come. Or directly it can come for 4 to 2, then 2 to 1. All such kind of possibilities are there. Okay, so when this kind of possibilities are there, what are the repetitions you see? Okay, now in this particular case, this is the repeated one. Okay, 4 to 3, this is the repeated one. Remaining all, how many lines are there? You check. This is first line, this is second line, this is third line, this is fourth line, this is fifth line, and this is sixth line. How many lines are possible here? 6 lines are possible. But every time you can't write like this, na? If they are asking from 7 to 1 or 6 to 1, you can't write like this. So here number of lines are 6. You remember 4 to 1 number of lines are 6. I will explain you by one simple shortcut. So 4 to 3, 3 to 2, 2 to 1. For example, if this is given, what these lines are called? 4 to 3, 3 to 2, and 2 to 1. 2 to 1 is Lyman series. So this is Balmer series, and this is Passion series. And all lines are called alpha lines because the difference is only 1. 4 to 3, difference is 1. 3 to 2, difference is 1. 2 to 1, difference is 1. When the difference is 1 between the two energy levels, the line is called alpha line. Okay, one more example you see, 3 to 1, 3 to 2, 2 to 1. If this is the case, which lines these are called? This is Lyman series, this is also Lyman series, and this is Balmer series. And here the difference is 2 beta, so this is beta line. Here the difference is 1, so alpha line. Here the difference is 1, so alpha line. Alpha line, beta line terms are must be known. Okay, if in these questions if they are mentioning series limit line, this word you see beta, series limit line, if this word is mentioned, you take n2 is equal to infinity, means the electron is out of the atom, it is not in the atom, so you take n2 is equal to infinity, it is gone, it is gone. Now number of lines formula is n into n plus 1 by 2, where n is equals to n2 minus n1. Number of lines formula n into n plus 1 by 2, where n is equals to n2 minus n1. We'll take the previous example only, 4 to 1. How many lines are there? 6 lines. We know the answer better. So n is equal to n2 minus n1, but that means 4 minus 1. 4 minus 1 is equal to 3 beta. N value 3. Number of lines is equals to n into n plus 1 by 2. 3 into 3 plus 1 by 2. Means 3 into 4 by 2. 4 by means 6. Okay. So this formula you can use. For example, 5 to 1. Difference is 4 beta. So 4 into 5 by 2. Means 10 lines. First you are writing n2 minus n1, then you are writing n into n plus 1 by 2. But what I feel is that better than this, we have another formula. Okay, now generally it is not given in the books. See 5 to 1, if you want to see what is n2 minus n1 value, 4. So what I say is you write like this, 4 plus 3 plus 2 plus 1, that is the total number of lines. If you are getting n2 minus n1 is equal to 3, 3 plus 2 plus 1. n2 minus n1 is equal to 6, 6 plus 5 plus 4 plus 3 plus 2 plus 1. The advantage of this is the first number indicates Lyman series, this indicates Balmer series, this is Passion, and this is number of lines in bracket series. So each individual series lines also you can get in here. The total lines are this one. But again, use your common sense better. Common sense is the most important factor here. 6 to 1 if they are asking, for example. Difference is 5. 5 means 5 plus 4 plus 3 plus 2 plus 1. That is equals to total 15 lines. Fine. So this is Lyman, this is Balmer, this is Passion, this is bracket, and this is Funch. Good. Very simple logic. But use common sense. If they are asking you 7 to 2 beta, what is the difference? 5. So 5 plus 4 plus 3 plus 2 plus 1 is equal to 15 lines. Up to here it is right. But in the same flow, if you say this is the Lyman series, that is the blunder. That is the blunder that you are making, because what is asking beta 7 to 2. 7 to 2 means the electron should get into the second level. Second level means there is no Lyman series beta. So first one will become Balmer, Passion, bracket, Fund, and Humphrey series. Humphrey series. Okay. So this formula will give you each individual lines, and that is much easier fact you can say. 2-3 formula I will give you. After that I will give you the differences, then we will conclude this topic. Energy is equal to minus RH into 1 by n square. This expression also you can use better. The energy of the stationary state is given by this expression, minus of RH. RH means Rydberg constant for hydrogen into 1 by n square. Otherwise, other expressions, these are not much useful, but you can remember 2.18 into 10 to the power of minus 18 joules into 1 by n1 square minus 1 by n2 square. Generally, when Z value is not there, you consider all these for hydrogen atom only. All these for hydrogen atom only. And some simple things are also you remember. The second line in the Balmer series or in the Lyman series, all these values you need to remember better. The first line in the Balmer series is called H alpha line. Its wavelength is 6563 H alpha 6563 angstroms. There is no need to remember, but these are general things that is asked in examination. Angstrom, these are we are discussing in Balmer series better. Okay, so I wanted to explain you the differences between line spectrum and band spectrum. It's very simple, not much complicated. Line spectrum means there are sharp, distinct, well-defined lines. Band spectrum means the lines are very close. These are also lines only, but these lines are very close, you see. So the band spectrum has many closed lines. Then line spectrum is of atoms, is the characteristic of atoms which are in the gaseous state. And band spectrum is of gaseous molecules. It is the molecules special spectrum, band spectrum. It is because of electrons jumping from lower energy level to higher energy level that we are calling as excitation, de-excitation. But this is due to vibration and rotational changes of molecules. Rotational and vibrational changes of molecules better. Generally, line spectrum is given by metal vapors, atoms, and inert gases. Inert gases, metal vapors, and atoms. And band spectrum is given by hot metals and molecules. Okay, so simply remember line means atoms, band means molecules. Then one another important one is absorption spectrum, absorption beta, and emission spectrum. Absorption spectrum is we were discussing hydrogen spectrum under the category of emission spectrum beta. So for example, you are giving some 100 joules of energy to some system beta, some atom or something you are giving. From this 100 joules, 60 joules is absorbed beta. What about the 40 joules? It is released immediately. Actually, it is not taken by the system. If you are going to analyze this 40 joules, that is called absorption spectrum. Absorption spectrum. Some amount of energy is absorbed by the system, but as we are discussing, it is not going to keep this energy with that one, and this is going to be emitted by the system later. And if you are going to analyze that emitted energy, that 60 joules is now in the form of emission beta, that is called emission spectrum. This 40 joules is not absorbed beta, this is called transmitted energy. If you are analyzing the transmitted energy, that is called absorption spectrum. If you are analyzing the emitted energy, that is called emission spectrum. Absorption spectrum and emission spectrum. In absorption spectrum and emission spectrum, the important difference is it contains dark lines on bright background, and this contains bright lines on dark background. Dark background and bright lines. And absorption spectrum and emission spectrum, both are discontinuous spectrums only, so no much difference is observed here. Absorption spectrum and emission spectrum, with one line I would like to explain you. You see, for example, these are the energy packets according to Planck's quantum theory and all. We say energy packets. Now let us say 1 2 3 4 5 6 7 are the energy packets, and your atom is absorbing these beta, or your atom is absorbing these x parts are absorbed beta. X parts are absorbed means if you are going to analyze these X parts after some time when it is going to be released, that is called emission spectrum. And these 1 3 5 7 are not absorbed, that is going to be wasted. Actually, that is we are calling here transmitted. If you are going to analyze this transmit energy, that is called absorption spectrum. Okay, don't think that absorption means absorbed. Absorption means not taken by the system. Emission means taken by the system and emitted. Done. So this is all about the spectrum. Done. Meet you with some other topics. Lakshma. Done.